Hello and welcome to GraphQL tutorial for beginners on YouTube channel of tutorialspedia.com. GraphQL has gained a widespread popularity among the integration professionals and API developers recently. So I thought of covering this GraphQL basics in this video tutorial. Here are the details of the topics that we are going to cover in this video tutorial. First of all, we will have a high-level introduction of GraphQL. We will explain what exactly GraphQL is, and then we will talk about GraphQL versus REST, and specifically, we will look into the points and concerns which are associated with the typical REST web services, and we will explain that why we should use GraphQL and how it resolves and it solves those problems. And last but not least, we will look into certain queries and examples in a live demo, and we will see the power of GraphQL, that how it solves the problems which are associated with the typical REST web service. So at a high level, if we talk about the REST GraphQL in general, and here is the official definition of GraphQL. GraphQL is basically a query language for your APIs and a server-side runtime for executing the queries by using a type systems you define for your data. So the name GraphQL somehow looks similar or analogous to SQL, but it's not an SQL, and it's not even related to that. The thing is that in case of GraphQL, what you do that you are generally exposing your REST APIs using multiple endpoints. But here in case of GraphQL, you expose a single endpoint, and then you give the flexibility of your client to exactly fetch or query whatever they want. So they query no more and no less. They only query what exactly they need. And I will explain in detail with a scenario that how using a RESTful web services we are actually doing sometimes we are doing underfetching and sometimes we are doing overfetching, and how these type of issues are mitigated and resolved when using the GraphQL. So let's consider an example scenario. Suppose that we have an order management system, a very basic example where we have customer and order data. And what we have in customer is that we have customer ID, we have customer's first name, customer's last name, customer address, and customer points. And then we have order, and in the order we have order ID, order description, order status, order quantity, total price, and customer ID. And there is a one-to-many relationship between the customer and the order, which means that a customer can place multiple orders, but a specific order is always associated with some specific customer. So this is the scenario that we will take into consideration, and we will see that how if we are going to use a typical RESTful web service is going to cause certain concerns and problems for us in terms of data underfetching or overfetching. So in a typical REST way of doing it, we will have multiple endpoints. We will have a slash order endpoint to get all the orders. We will have a slash order order ID, which is the path variable and a path parameter. So in this template style, we will get one single order based on the provided order ID. And then we have another endpoint slash customer to get all the customers list. And we will have slash customer customer ID to get us to get details of our specific customer. So you can see that for this scenario, we have to retrieve the data about the orders and the customers, we will have to rely on 4 different endpoints. So if we want to fetch the data for all the customers, we will use slash customer, and you can see we get an array of all the customers. We have customer ID with the ID 123 and another one with the ID 124. And observe that we are retrieving all of the elements which are provided from the server. There is no way that we can filter it out, and we ask the server that provide us only those information, only that set of information that we need. Like as an example, in this scenario, maybe you are developing a mobile application, and in mobile application you only need the customer ID and you don't need the first name and the last name, address, and points, but still you are going to receive it. And it can be vice versa. Maybe you need only customer points, but you are still getting other detail like customer last name, address, first name, etc. Now if you want to fetch a specific customer, you will have slash customer slash 123. So in this case, you are getting all the data for your customer 123, but again you have no control, you are getting all of the data. So the server is not dynamic in this nature, and server is going to return you all the data. So suppose that the same endpoint is being invoked by the mobile application in a web application, and in the web application, the data of their interest is customer ID and also their first name and last name. But maybe in the mobile, the interest of the mobile application is only customer ID and customer points. So in this way, you are forced to get all the data, no matter what exactly you need. So you will have to take everything, then you will have to filter it out. You will have to ignore certain elements when you are showing it, or whenever you are going to consume it on the front end or on the client side. So it's purely up to you, but in either case you are going to receive all the data, and your network bandwidth is going to use a huge sum of data. In this case you see only four elements, but imagine a scenario where we have a very complex case of JSON, where we have dozens of elements and we have further nesting of those elements, and we are retrieving quite a huge sum of data with multiple MBs or maybe even more than that. So in that case of scenario, if you are going to make a lot of requests to the server, so it's going to affect both. It's going to affect the server, because server is going to be in a situation where it has to return a lot of data on so many calls. And additionally, you on the client side also going to use a lot of data. If your client, like a mobile application, is being used by a customer, and their data plan is some restricted some limited data plan, so they are going to consume their data plans unnecessarily for some data which is not going to be consumed, which is not going to be utilized in either case. Same is the case for order. You are getting all the details of all orders, no matter what exactly is of your concern, or of your interest. And if you are going to restrict yourself to a certain specific order, still you are getting only one order. But again, the elements that you are receiving in order might not be of your interest in all scenarios. So the problem that we identified is that we have two problems here basically. The first problem is that we are getting data overfetching, which means we are getting certain elements which are of not our interest, and we are getting it forcefully. I mean, we have no choice. We have to receive it in either case whenever we are going to hit that endpoint. The second problem is underfetching. Like imagine a scenario where you're building an application, maybe a mobile application, to show the customer and their orders. Here in this case, it's important and it's necessary for you to first call the slash customer and get the customer ID. Then based on the customer ID, get the information of the customer, and then you call the order slash order or slash order ID endpoint, and then you are going to get the order details. So basically, for us, for maybe for one page on your web application, or maybe for a single form on your mobile application, you are bound to call multiple endpoints. So in this way, you are unnecessarily having a lot of traffic going back and forth over the network, and it's consuming a lot of data. It's causing a lot of throughput issues on the server side as well. And secondly, imagine a scenario where you got the data correctly for a specific customer, but next you made another call for the order, and maybe when calling the order endpoint, there was some network glitch or there was some problem on the server side, so you did not receive the data for the order. So in this case, even the data that you received earlier for the customer is meaningless, because the requirement for your application is to show customer along with the order. So if you don't receive the success response for either of the two, then any other endpoints that you invoked, the data that you received becomes meaningless. So in this way, you are in a situation where, because of underfetching of the data, you try to call multiple endpoints, and now you are in a situation where we are either overfetching the data, or in other case maybe you have the problem of not able to invoke a certain endpoint, and because of that, all the data that you retrieve for the other endpoint from the other endpoint becomes meaningless. So to resolve the issue that we have here, I explained the same thing which I just mentioned, that you have multiple endpoints. So that's a major issue, because you're calling to multiple endpoints to get the required information. And as I stated before, that even if one of the endpoint doesn't return you the data, then the data that you retrieve from other endpoints, and then it because the data that you are receiving from multiple endpoints, you might need to aggregate the data, and the meaning of that data can be extracted only if the data for all of the endpoints is received. So if any of the endpoint doesn't return you the data, then you get a problem. And secondly, because the multiple endpoints were calling, so you are having a lot of network bandwidth being utilized, as I stated before. Then, as I explained, that you have data overfetching and underfetching, because you are getting unnecessary field, and also you are not getting all the information in a single call. And additionally, on the client side, you will have to make sure that you're doing the aggregation, you're doing the filtering of the data as per your requirements. And then another problem is that you have a very tight coupling, because if you have to make any changes on your API endpoint, then you know that everyone who is using these endpoints is going to be impacted. So what you do is that you go with the versioning, and it's versioning is inevitable in this case, because if you don't do the versioning, then your existing clients are going to be impacted. The result is that for even small changes, you have to go through a complete long process of making the changes, and making sure that it satisfies the needs of all the customers. And maybe you are making changes for certain elements or certain data set in your API for only certain customers, and it's of no interest for other customers, but still they will have to go through this. So these type of problems you typically face if you are going with the conventional approach of implementing your web services using the REST endpoints. So the problem that we explained here can be solved using the GraphQL, and GraphQL comes as a solution to these problems. So the good thing about GraphQL is that it's a single endpoint for all API calls. Usually it is slash GraphQL. So you don't have to create so many endpoints. You will not end up with a big list of endpoints for your customers or for your clients to understand and to consume. Rather, you will expose a single endpoint. And now this smart flexible endpoint is going to handle magically the everything that the client is going to request for. So what happens is, in case of GraphQL, is that it works based on the concept of queries and types. So what happens is that the client, whenever is going to retrieve the data, client will specify smartly that what element exactly they need, what kind of data they need. If there are any relationship between the data, those can also be identified. So the client will be receiving only whatever is of their interest, nothing more, nothing less. And since client is going to make a single call to this GraphQL endpoint, so in this case the number of API calls are also going to be reduced, because client doesn't have to call once to get the customers, then get all the orders, then fetch the specific order, and then build up the client side application. Rather, they will make a single call. And if it's related, so maybe the client will specify the customer that and say that I need customer ID, and then I need all of the orders that are associated with that customer. They can make further filtration as well, that I need only those orders which have been shipped. Maybe I need only the last two orders. Maybe I need the first two orders, or something like that. So in this way, the client will be receiving an aggregated form of results directly from the server. So internally, server on the server side, the server may retrieve the data concurrently from the multiple tables or from the multiple sources of data. But for the client, it's not the headache of the client. Client will receive the data in the aggregated form. So what essentially you resolve the problem of underfetching, and you resolve the problem of overfetching, because nothing more, nothing less. Only whatever client needs has been returned back to the client. Now that we have made the problem statement clear and the solution also, let's see exactly in a live scenario that how we can create the queries and how we can retrieve the data. So for that purpose, instead of creating a separate application and looking into that, what I will do is that I will use the GitHub GraphQL API, which is available on api.github.com/GraphQL. So once you try to use this GraphQL API from GitHub, you will have to allow the authorization, because they need certain permission, and only then you can use a runtime explorer, which provides you the details live, and you can play with that explorer and see the live results coming in for the repositories that you have on the GitHub. So I'm already logged in, and I have authorized the browser and to authorized GitHub, and now I'm able to make the queries. So you can see it's GraphQL based Explorer. So here you can play with the actual queries, and these queries will GraphQL queries will go to the GitHub server and respond you with the data. Like in this case, you can see that in the query I'm providing in the viewer only login. So what it will do is that it will provide me the name of the user. So if I click on this, you can see I received my name Ajmal Abbasi as the user. Additionally, if you want more data, you can do that. For example, I want avatar URL as well. So now if I click it, I get login and also the avatar URL. So basically, you see that whatever I need, only that information I'm getting. If it was a typical REST API and I sent the user ID, what I will receive is the complete bunch of data for that user. Maybe most of that is relevant for for my specific use case. So in this case, using the GraphQL, you are retrieving only what you need. You are not getting any unnecessary set of data. Now let's make another query. So in this case, what I want is that I want the last three repositories for this user. So what exactly I need is that for those repositories, I need the name and created at. So I will be getting this information for the last three repositories. Now if I try this, you see I got the response, and I see that there is a Spring REST Web Services CRUD which is created at 2019 926. Then I got another one, and there is the third one, docs API M. So basically I retrieved the three repositories for this user using this option. So if I don't want the created at, I can simply remove it, and you will see that I will just get the name of all the three repositories because I specified last three. If I specify first, and if I specify one, so I want only the first one, you see that I'm getting the name of only the first repository from the using this GraphQL query. So this is how basically you utilize the power of GraphQL, and you can play with the queries and you get the results. And this in this tutorial, I only covered the basics of the query, and query is only to get the data from the server. But if you want to do the other operation like update, delete, or add any data, for that we have mutations, which I'm not going to cover in this video tutorial. I will try my best to have additional videos covering the topics and concepts related to mutations in subsequent videos. So please don't forget to subscribe to the channel and press the bell icon so that you receive the notification for any new video uploaded. So that's it from this video. Thank you very much.